Hi friends, so this is basically a simulation lab for multicast. Here in this lab I am not going to explain the multicast technology in detail, which I am planning to prepare another video for the technology part to explain in bit detail regarding the various aspect of multicast and where it is used and what are the technologies involved and like details like how to configure it on the network, what all the supporting protocols you have to use while configuring multicast over your network, how to troubleshoot. So these details I will be planning to create another video session for this. So the purpose of this video is to explain the lab and show you that how multicast lab environment is created and how it is working. So also this is the main thing what I will try to explain over this video. And basically the better part of this multicast lab scenario is that I am trying to simulate an exactly the result. Like usually in the multicast lab session you have to create a IGMP join group and you will be checking whether the source and receiver is trying to join on the group, and maybe you will check the mapping that will be created over the RP for the source and the multicast IP, but it sometime it don't clearly give you a idea what's going on and whether this is enough for the multicast to be working on the real scenario and on the real field. And even if you are getting all this mapping also, there will be situation that you will not be getting the multicast stream on your receiver, because apart from all this theory kind of thing and from the lab section, ultimately the service has to be delivered for the respected receiver. I mean the multicast video, whatever the streaming has to be delivered on the multicast receiver. So if this is not happening, then it will be hard to troubleshoot and to explain. So let's I will briefly explain the lab setup. In the lab setup, we have a multicast source here and a receiver here. These two devices is I use a virtual OS of Windows operating system, and over the Windows operating system I have configured a VLC media player for streaming the multicast, and also on the receiver side also here I have a VLC media player to receive the multicast streaming. I will show the configuration for that VLC also, and this is an OSPF backbone, OSPF network through which our communication is being established, and we have put one ASA in between, because normal multicasting without any firewall is bit easy compared to a real network. It will work very simply, but situation will be different in the real networking, on the production networking, on the field, because there will be always firewall in the network from the outside to the inside zone. Like you will be having your data center setup in the back of your firewall, and it has to be protected. So usually we will be having a firewall in middle. So when multicasting is coming through a firewall, it's bit tricky, and and it has to be very carefully done. In my current scenario, I just pass the multicast through my firewall, and fine tuning part is not done yet. So that I will be completing in maybe in another video session. I will be completing some fine tuning for this lab. So I'll as labeled on the topology on the diagram, the network has been using a point to point IP, because there is no shared devices in between, and it's just a point to point IP is required for establishing a connectivity between the devices, and over that point to point network we are running OSPF for the connectivity. So as labeled, the IP has been designed. So for this segment over here we will be using 10.1.1.6/30, and this is actually not the network, but for reducing the labeling over the topology I used a scenario like this. So 6.30 will be used over this fast Ethernet 0/1 interface for this router, and 2 will be for the ASA. So similarly for all the router will be configured in the same way. For this router, fast Ethernet 0/0 will be configured with the 17, and the other interface on the other router will be configured with 18. So this is the method I am following for the IP address. So let's open up one router, and I will check the OSPF neighborship. So yeah, this device is being OSPF neighbor with the left and over the right side ASA. That's fine. So no need to check on this device. I will check over here also. This router has been in OSPF neighbor with this ASA also. And one more thing we have done on this network is we have configured VRF also. So we did VRF because this topology we created based on some of our live environment, and on the live environment we had a VRF setup also, which is not a full stretch VRF, it's a VRF-lite because of the equipment compatibility, because the device what we are using will only supporting VRF-lite. So lite is being implemented. But on the ASA there is no VRF configuration. there is some limitation. So we didn't configure any VRF on the ASA. So as it is local for the route will be passed from the router towards the ASA in the global routing table. Which you can see here, show routing. Yep. Okay, so here you can see the routing which we configured. So 12 network is already learned here, which is learned to the outside of my interface. So see that 12 is between my multicast source and the first router. So IP for my multicast source is 10.1.1.1.14 and its gateway is 13. Its gateway is 13 over here on the router interface. So my multicast source will be 14 and my multicast receiver in this scenario is over the network 10.1.1.20. It's also a /30 IP which have only two usable IP, and 21 is the gateway and 22 is my receiver. So this I already put one label here. So this is the 21 over this interface and 22 for my receiver. So you can see that OSPF is being configured between the network, and all routes is being exchanged between the devices, and the ASA can see my source and my destination route is visible in the ASA. And now I will just show the VRF part also. Okay, VRF is not configured on this device. It's all route is coming to the global routing table. Let's go to the other device. Here you can see there is no route on the global routing table, so we will check the VRF. So my route is isolated inside the VRF named as ITS. So you can see that all route has been learned from all the devices through OSPF. Now what I will do is I will open up my Windows machine, and we will check the multicast streaming. So for that we have to use VNC because it's running over a simulated environment. And I have 5 also. So let me go and check the IP for these devices. Show IP interface. So, oops. IP config. This is 14. So 14 is my source device, So I'll just put a notepad in the background to easily identify this as my source. Standard 1.1.14. It's IP standard 1.1.14. Go to font size, just increase a bit, 18. That's perfect. So this machine over you see here is my multicast source, which is this machine actually, and the other, this one is my receiver. So I'll put one more notepad here to avoid confusion. Receiver IP standard 1.1.22. So that's it. So let's set up the multicast streaming part, and so you have to go to your source first, and from the source, so you need some kind of video to stream and to simulate the multicasting. So I have downloaded some videos and I put it on the videos file here. This is my video that I am going to multicast over the network. So there is a bit slowness for response from the virtual device. So I'll open the VLC media player, and from media player you have to go to media. In media you have to select the section stream, and here you have to add the file. So click on add, choose the file, open it, and by default this option will be in play or NQ, or it is not coming in stream by default. So put it on stream, give next, and here you have to choose the format. So I'm choosing the RTP and MPEG transport stream. Add it. So here you have to mention your multicast IP for this source. So currently I am using 239.1.1.1 over the port 5004. So if you are using certain CCTV, that has to be your multicast source, and there will be receiver inside your data center to where you will be streaming receiving the stream. So in the CCTV there will be option for providing the multicast IP address. In the modern IP CCTV there are options for this. In the low end CCTV there will not be option. So in the multicast option you have to provide your multicast IP address that you assigned for this particular CCTV, and the port for the multicasting, and so that is what I am doing here actually. So, as we do not have a CCTV and it is very hard to simulate, I am putting the same setting for the VLC here, and yeah, that is fine. Give next. So, here while you are doing the simulation, you can see there is a destination port. Port is mentioned, yes, is 5004. Destination IP address is mentioned 239.1.1, but there is no TTL value mentioned, which is very important. So, we have to make a slight change here. We have to mention as TTL some value. In my network about 10 will be fine, because I do not have much devices, but in your network you should be have a scaling of the network devices and put an appropriate value here, but make sure the TTL is a bit high number, so that it won't expire in transit and the multicast packet will be dropped. So, give a better value here and give the stream option. And on the other device, on the this is my receiver, okay, on the receiver side, go to VLC media player, and from the media option go to your here we are receiving the multicast stream. So, you have to give a different setting, open network stream. I have previously tested this multicast. So, we have the same setting here. So, this is what you have to give. You have to mention the RTP, which we have already given on the other side. It is RTP format, and colon / your multicast IP 239.1.1.1 colon your port number 5004, and give play. So, if your network is fine, you should receive your multicast stream. Yeah, we are able to receive the multicast stream, but you can see there is a delay, there is a jitter that you can experience for the video, because my fine tuning part for the ASA is pending, and I did not done any fine tuning on the ASA, and I did not check the QoS part for the traffic over the routers. So, if the firewall start processing the security pipeline for the multicast traffic, then it will be very hard in a production environment to spare the resources for other actual inspection, where the inspection is necessary, because multicast traffic will be coming in a huge quantity, and if firewall started processing all of the multicast traffic, then the resource will be very highly utilized for this purpose only. So, if you know that multicast is coming from a trusted source, for a better multicast experience, you have to put a pre-filter policy for the firewall, so that the security pipeline can be skipped, but it will be highly based on your network and based on the trust over the multicast traffic. You can fine tune based on your importance and your trusted for the traffic of the multicast traffic. so that is dependent. So that I didn't done it for my network. And also you have to apply some QoS if your devices on the network, the routers what you have applied here, if it is other traffic is consuming more bandwidth, then absolutely you have to apply some quality of service part also. So that is not covered in this video actually. So I'll be just showing for the basic configuration part also, very basic configuration. I am not going into a detailed session which I will plan in another video. So here you can see that I am streaming the video from my sender, and on the receiver part I can view the video, but as you can see there is a delay. Now the video is actually been finished. I believe it's been finished, and no, it's still running. Okay, fine. So here you will be not able to see the video because there is a option while configuring whether to show it on the local device or no. So the default option is it won't show the video locally over the VLC. So that has been disabled for now. So it's not showing. So this is the application part, like of the lab. And while going to our networking part, we have on the backbone network we have OSPF configured, and we have a ASA firewall, and we have an multicast configuration also. We use the protocol independent multicast here, which is a better approach in my case. So the unwanted like the multicast traffic will not be flooded into the network, so which is the best option for me. And in my network we have configured a RP over here. So simply RP is the point where the receiver and the source meet together. Without an RP, multicast is not possible on a PIM method. On if you are following the multicast PIM method, then RP is mandatory. For the first time this is very mandatory, but later there will be some difference in the working. So here is my RP. So basic thing I have to check is from all the devices whether it can learn about the RP and it can reach to the RP over the network. So you can see this is my, I just named it as my CE router, and show run session up. I configured its loopback 0 interface as my RP, and loopback is under the VRF ITS. So show IP interface brief. My loopback is 1.1.1. So this IP should be reachable, and RP should be known to the other device who participate in the multicast in this network. So we will go to 7206. 7206 show IP PIM RP. Mapping. Here there is no mapping on the global routing table, so I configured it on VRF, under the VRF. So we have to check the VRF part. So IP VRF ITS RP mapping. Command is bit different. So routing VRF-lite. Yep, RP mapping. So here you can see there is a RP mapping towards 1.1.1, which is our RP in this network, and currently there is group joining for the 224 IP address, which we will discuss further in the later videos. So jump into RP. We will jump into RP, and here the one more important thing we have to check is the multicast routing table. Show VRF. I'm checking for the VRF, but because I didn't configure VRF on the entire devices, because it's a VRF-lite configuration. So I want to put the mix of all to be on the network, because live network is always like it will be always a mix of all. Some devices will be supporting, some devices will be not supporting, especially when you are going for a brownfield scenarios. So I want to try the same over here also. So I configured VRF on some devices. I didn't configure VRF on some devices, and I didn't configure VRF on the ASA. So let's check the M route over on the VRF. Show IP M route. Show M route VRF-lite. So basically M route is the multicast routing, and this is the multicast routing table. Here you can see the IP for my source device, which is 10.1.1.14, and its multicast IP mapping has been reached on the device. So this will present in the router for some time, in the RP for some time, and if the receiver stop the request for asking for this particular multicast traffic, then the RP will remove this routing from its routing table. So maybe if streaming is not active, then this multicast route you will not see in the multicast table over here. So this is actually based on there should be demand for the traffic, then only the RP will keep the routing for that particular destination. And I will simply show what I have configured on the ASA also. I just put one policy, show IP, show access list. So this is my list for the multicast, so which permit traffic from my source. If the I put it for the under 239 range, and it has to permit the traffic towards any of my destination, from this source towards any of my destination. And you can see there is a hit count, and it's being in working now. So and I applied this on my outside interface. Show run access group. So you can see this is named as host, and it is applied on my outside interface for the inbound direction for the incoming traffic. So if I remove this policy, then multicasting will not be working. And there is some few other rules also which I configured, but it was for the previous troubleshooting. I need to allow ICMP echo request and ICMP echo replies over the network, so that I can ping from my source to destination, destination to source. So that I allowed for the troubleshooting part. So basically this is the thing, and I will I just missed to show one more thing on the PIM configuration which I did over the interfaces. So IP PIM interface, this better we have to look on a non VRF device. So IP PIM. So this is because on the previous device we have configured VRF. I don't want to again enter the VRF command line, so I just put show IP interface on the first device. So there is no VRF configured, and you can see that on the all the interface that is participating in the multicast forwarding, we have to enable PIM, protocol independent multicasting, which is the protocol facilitates multicast in this network. So on this device, on the firewall, on the other router over here 7206, we have to enable PIM, which is very important, and you have to check the ping neighborship also. So this is it, and maybe if I am doing another video session, I'll try to explain the technologies, like we will be covering ping and multicasting, a theoretical way, and regarding the IGMP and the dense mode, the difference between sparse mode and dense mode, which will maybe we will try to cover over the next video related to multicasting. Thank you.